We've been building our dream home for a while now, and we've been doing our own electrical. Along the way, we've noticed some very common mistakes when wiring up things like outlets or receptacles. Obviously, the consequence of doing this incorrectly is at least electrocution or maybe a short in the system. And the worst possible outcome would be a house fire. One of the most common causes of house fires is electrical. So let's go over some of the most common mistakes made by DIYers when they're working on receptacles and outlets, and how to avoid them, and some tips and tricks to wire up an outlet perfectly. One of the first mistakes that I see DIYers making when wiring most anything, but especially outlets, is stripping back the sheath on a wire like this. This is called Romex, and it just has an insulative sheath on it. The problem is, to expose the wire, you need to trim it back, right? What I see people doing is reaching for things like a knife or maybe some scissors and trying to figure out how to cut this sheath. The propensity is to try to twist it as you cut, or maybe you try to, kind of carve it away, something like this. The problem is that you're going to potentially nick the wire underneath, and you could put yourself in a situation where maybe this is all wired up correctly at the receptacle, but back here you end up with a short between these two wires, and that can cause a fire. So while this looks really good, looks like somebody did a great job cutting the sheath off or stripping the sheath, if I pull this back just a little bit, and if you look really closely, there's actually a couple of nicks between the red and the black wire there. And that's what happens when you cut too deep. This is kind of insidious because you wouldn't even notice it, because unless you really paid attention to this cut area here, the tendency would be to think that you did a really great job cutting all the way out here. The right way to strip wire is actually to use a pair of pliers that are designed for this task. These are actually called Romex pliers, and they're made by a company called Klein. And they have a special portion of the pliers right here that are designed to cut just the sheath off of wire. They even tell you the wire size and the number of conductors that it's designed for. And if you use these properly, you make the perfect cut. It won't cut the underlying wire or the insulation on the wire, it'll only cut the sheath itself. So what we could do is come back here and take this portion of the sheath and make one nice clean cut, and I'm squeezing as hard as I can. And now we can simply remove this insulation, and we have a nice clean cut here with no damage to the underlying conductors or wires. The second mistake I see a lot is stripping wire, and again, reaching for things like scissors or a knife and trying to either shave the wire back or make a circular cut around here. Again, the problem with that is that you run the risk of either nicking the conductor itself or even making the conductor brittle. If you were to make a nick in the wire and then bend it several times, what you don't realize is happening is the copper is being weakened. And when that happens, it will not pass electricity as efficiently. And you might get away with it. But if you start running some high amperage or high power devices over time, and this wire is bent inside the box, it's like a kink in your garden hose. And again, you can't see it, but that nick can be a major fire hazard. Not so much an electrocution hazard, but it will cause a lot of heat to build up in the wire as those electrons try to move down the wire. Again, the right way to strip wire is to use a set of pliers that are designed for this exact task. These same pliers have a measured stripping gauge right here, and they're designed so that when you squeeze as hard as you can, they only strip the sheath off of the wire, the insulator, and they don't do any damage to the conductor. So for example, this wire is what's called number 14 wire, or 14 gauge wire. And right here on the pliers, they have an indication for number 14 wire. So what we can do is just place the wire inside the number 14 conductor, squeeze firmly, and guess what? The sheath comes right off. It's very clean and very simple, and there's no damage to the underlying conductor. So now you can bend this conductor and you don't run risk of building heat in that wire. These pliers are a very good investment, even if you're just going to be doing a little bit of electrical work, because just these couple of things could reduce the fire hazard exponentially. I think these are probably around $20, and these are designed to do quite a few other things, but those are just a couple of the main benefits that you'll find with these pliers. Another common mistake I see when people are wiring up receptacles is the wire size. This one is really tricky and it can really sneak up on somebody with not a lot of experience. The difference between this white wire and this yellow wire is very, very small. It's a very small difference in wire diameter. This white sheathed wire is what is called number 14 wire, and it's most commonly used for lighting only circuits. It's pretty rare that you'll see this on an outlet circuit. That said, it does happen, and it's very important to notice that. This wire is number 12 wire, and it's most commonly now used on receptacle circuits or outlet circuits. If you were going to wire up an outlet or a receptacle and you notice that there is number 14 wire going to that, you might really think twice about putting a receptacle on there, because the temptation might be to plug in something that takes a lot of juice. And if the wrong circuit breaker were present on this particular circuit, what would happen, instead of the breaker flipping, the wire would melt. There's simply not enough wire to carry the electrons necessary to power something like a vacuum cleaner that would take a lot of juice, or maybe even a power tool. So if you see something like this when you're wiring up an outlet, you might stop and just ask for some help and make sure that the wire and the breaker and the receptacle are all matched so that you don't inadvertently put yourself in a situation where you could cause a fire. The next mistake that is really easy to do if you're not careful, it's a little bit confusing, but it's what's called reverse polarity. It's when you put the wrong wire on the wrong screw. You'll notice that there's a silver screw and a gold screw on an outlet. The gold screw is designed for your hot wire, or in this case, our black wire. This is the one that carries the current from the circuit to the outlet. It's very important because the outlet actually has a configuration on the front, and when you plug something into it, it's designed so that the hot wire is on one side and the neutral wire is on the other side. And if you inadvertently put the wrong wire on the wrong side, you are reversing the polarity of the outlet. This could have a serious consequence depending on what you plug into it. So the right thing to do is to check the back of the outlet. If you look really closely, there's actually some fine print on the rear of the outlet here that reminds you that gold is for hot and silver is for white, or it'll just tell you the neutral wire. Sometimes, in rare situations, you'll reach in to wire an outlet and you will not have black and white wires. The right thing to do is to figure out which one is the neutral wire and make sure that it goes on the silver terminal and that the hot wire, in this case the black wire, goes on the gold terminal. The next mistake that I see people making is buying extremely cheap outlets. And while these are designed to be safe, there's a few things that can make them particularly hazardous. One of these is this small hole that's on the back of the outlet. They call it a jab or whatever you want to call it, but it's designed to fit only a number 14 wire. There's a specific reason for that, because a number 14 wire is rated at 15 amps of current. If you were to put a wire larger than that in the hole, you run the risk of overrating the outlet, meaning number 12 wire on the circuit probably means that there's a 20 amp circuit breaker on there. And if you were to put this into a 15 amp outlet, there's a very high probability that this outlet could get too hot and catch on fire. So they deliberately designed it so that unless you break the outlet, you're not going to be able to put anything other than a number 14 wire in there. So you can push the wire in. But the question is, what kind of contact is that making inside this outlet? The answer is we don't really know. It's really a big guess, and that's what makes this so dangerous. If we were to put any substantial amount of load on this circuit, it could create heat, and that could of course cause fire. There's a small slot here on the back where you could push in a screwdriver to release the jaws that are holding this wire. But you might be shocked at just how easily this wire will come out without using a screwdriver. If we just twist and pull, we can actually remove this wire from the outlet itself. And quite frankly, that type of a connection in electricity is just dangerous. So I would recommend using a higher quality outlet, and don't use these stab-in connectors. Even if it's easier, you're already putting yourself at a disadvantage, because the temptation is that nobody knows when they plug something into this how it's wired on the backside. So if somebody were to plug a vacuum or some sort of high amperage device like a power tool in here, there's a chance that this could melt and catch on fire. If you're really benefiting from these tips and tricks, please take a moment and like the video. It really does help spread the word. And share the video. Let other people know these same things to save them from electrocution or a house fire. If you really like the video, go ahead and subscribe. We've got more tips and tricks coming. All right, back to the other mistakes. The next mistake is a sneaky one, and this is really just an opportunity to give your home or your shop or whatever you're wiring a little tiny upgrade. If you look very carefully at these two outlets, you will see that they actually have a slightly different amperage rating. This one is rated at 15 amps and this one is rated at 20 amps. You can actually tell right off the gate because see how there's a small ear on this outlet right here? There actually is a plug that is designed for 20 amps only, and it will not fit into a 15 amp outlet. But let me tell you, the amount of homes that are wired up with an outlet that looks like this, but is on a 15 amp circuit, but which you can plug something into that has a plug like this, is pretty ridiculous. So this is just a small change in price. I think these were around 50 cents difference, but the internal components are completely different. This one is designed to carry 20 amps of current. And so for 50 cents more per outlet, you can upgrade to a much higher quality outlet. You don't lose anything by putting this outlet in because all things that will plug into a 15 amp outlet will plug into a 20 amp outlet. And therefore you're just making your home or your shop that much safer. One of the other mistakes I see people making is using these type of connectors on the back. Of course, this is rated at 15 amps and it has a small plate here that when you slide the wire into and you screw the screw down, the plate compresses the wire. And what you end up with is the total wire connection that's being made is the length of the wire that's exposed to this plate. And that's what's able to carry electrons. The problem is that's not a lot of wire to make a connection. If you look at this outlet, which is rated at 20 amps, it does not have those plates. The reason for that is the wire is designed to be wrapped around this screw. And the goal here is to make a very good connection with a lot of surface area. If you think about it, you want the wire to make as much contact with the screw and the underlying plate as possible to transfer electricity. If you were to put this outlet into a 20 amp circuit and simply slide the wire in and screw this down, while it's easy, it could build heat and of course that could cause a fire. The next situation that can sneak up on someone is the stripping of the wire and the sheath that goes around it. Let me show you two ways this can be done wrong and a trick to make sure that you get this sheath cut back to the correct distance. So if you strip the wire back correctly and then you bend this wire around and make a loop, and that loop goes onto the outlet. The problem is if you don't strip the wire enough like this and the sheath actually starts to wrap around the wire and you hook it on and you go to attach the screw, the problem is that the sheath will get in the way of the wire. If you look really closely, this insulation is actually underneath the screw itself, and the effect is that the screw does not make good contact. The other problem is if you overstrip the wire and then you put the small loop on the outlet, now you actually have wire that's sticking out behind the outlet itself. And if this were in a metal box or there were other wires there and you did this to more than one of them, there is a chance that something could touch and short or cause an arc and electrocute you, or obviously it could cause a fire at some point. Let me show you a trick to make sure that your wires are always stripped the exactly correct distance. On the back of nearly every single outlet out there is what's called a strip gauge. It's actually right here, and what we can do is simply slide our wire into that and then hold onto it and mark it with our finger. And now that's the distance that we want to strip on this wire. If we were to create an ear, it would be the perfect distance. And now our wire is neither exposed on the back and our insulation is also not impeding the wire from fastening down to the screw. The next mistake is looping your small loop incorrectly. There actually is a right way to do this. If we put this loop onto this screw in the counterclockwise rotation, what we'll notice is that as we tighten the screw down, the wire actually tries to run away from the screw. it will tend to try to depart this direction. And the reason for that is it's grabbing the screw head, and the screw head is actually pushing it away from the screw because of where it's positioned. And that would put us in a position, though even we've done everything correctly, the contact that the screw is making with the wire is particularly poor. If instead we loop it in a clockwise fashion, this direction, we'll notice that as we put the screw in, the wire has a propensity to pull itself into the screw, making a very good connection. So as you're looping your wire, make sure that you're putting the wire in a clockwise orientation for the best connection. The next mistake I see is people trying to put two wires on a single screw. So let's imagine this outlet's already here, and maybe you're trying to add an outlet, or maybe you want to add a light switch or something like that. You simply loosen this screw and you try really hard to sneak another wire underneath there, and you get it in there and it fits and you can't believe it, and then you tighten this down. The amount of risk that you've just created is ridiculous, because these two wires will never seat well on this outlet, and they will always have a poor connection between all of them. And what you've actually done is create a major fire hazard. Let me show you the right way to do this that's actually very safe and allows you to do the same thing a little bit differently. So the right way to extend an outlet's power transferring ability is to do what's called a pigtail. So let's say that we have these two wires that we want to bring together at this outlet. What we're actually going to do is add a wire to our outlet that will allow us to bring the power out and then simply connect it through a wire nut. So we can just take this small piece of wire like this and create what's called a pigtail. And this is a very safe way to extend power, because no outlet is actually designed to have two wires on a single terminal. So what we can do is attach this single wire to our outlet, and we make a very good connection through the single wire. And now we have the safe wire connection. And now we can bring them all together outside and use either a wire nut or a lock nut like this one to bring them all together in a safe way. This is called a lever nut, and you simply bend the tabs up like this, and then you can just slide each wire in and then lock the nut. And now we've made a safe connection using a single wire approaching the outlet and then these two exterior wires coming together. You could of course do the same thing here with a wire nut, and now you've safely created a nice connection. And so for the last common mistake that I see is really not getting good torque on the screw. Of course, the temptation is to use a standard or a straight screwdriver because they provide a slot. And so you'd be tempted to use one. But if you've tried that, you've probably found out already it is extremely difficult to get good torque. The screw simply strips out. So you probably found yourself grabbing what they call a Phillips or a star screwdriver, and that allows you to get pretty decent torque. The problem is, as you get closer to the end, the screws have a tendency to strip out, or the bit will try to turn inside the screw. If that happens, it's almost toast because you'll never really get that tight. But there's a trick here. If you notice very closely, inside of that screw is actually a square head. And so if you were to use what they call a Robertson bit or a square bit, you can actually get inside the square portion of this screw and have extremely good success. Using a square screwdriver is the way I have found the safest to get the largest amount of torque on a screw, and that makes this connection that much better. These of course have a rating on them somewhere. I think it says 14 inch-pounds of torque. Of course, most DIYers aren't going to have a torque wrench, and I don't think most people even torque these. But what you're looking for is that you really want to make sure that these connections are solid. And I have found that a square bit gives you the most positive connection possible. Now, there is another little secret trick here I'll share with you, and that is another bit that is manufactured to fit just exactly these screws. It has all three bits, a standard, a square or a Robertson, and a Phillips all in one. And those can be really great too. I have found a little bit of challenge though in finding which exact outlets they fit perfectly. And so if you have one of these, give it a try. They make more than one size. This is a number 2 bit, and that may be why this is such a challenge. If you find one in a number 1, that may have a better success rate. Personally, I have found that the Robertson or the square bit has the best success rate in getting these torqued down tightly. That does it for this video. If you really enjoyed these tips and tricks, please take a moment and thumbs up the video and give it a share. Help other people benefit from these common wiring mistakes. Maybe you'll save them from electrocution or maybe even a house fire. If you really enjoyed this video, please go ahead and subscribe. There's more videos like this on the way. And happy wiring. Wow. That's a new everything.